Good day and welcome to VMworld 2021. The topic for this session is on Rogers, driving 5G network evolution with VMware. VMware is glad to welcome Bryce Mitchell, VP of Core Network Engineering at Rogers Communications, to VMworld 2021. Bryce has been working in the industry for 25 years and has a unique background of traditional telecommunication engineering, cloud computing, and software development. He's a keen advocate on applying the best methodology of web-scale engineering and modern software practices to the communication industry, especially related to 5G and edge computing. In this session, we will have Bryce share his thoughts on Rogers' cloud deployment and 5G vision. And then Stefan Andrieks, who is from VMware Professional Services Organization, will talk about how we have deployed the Telco cloud platform at Rogers. After this, myself, Dharmarajan, Principal Solution Architect in the Service Provider Edge Cloud Business Unit, will share with you how VMware is well aligned to meet Rogers' 5G and NextG vision. With that, let's get started. We have got a lot of ground to cover. What you see here, this shows VMware can support a true multi-cloud strategy. The focus for this VMworld. We will talk about the various multi-cloud at some point in this session and how it relates to the Telco cloud. This shows a standard disclaimer that all of you would like to familiarize yourself with. Let me pause for a second so that you can look through this. We will start this session with Bryce Mitchell from Rogers speaking about Rogers' mission, Rogers' current telco network deployment based on VMware platform, and Rogers' 5G vision. Following this, Stefan will provide you key highlights of the deployment architecture at Rogers and how with multi-vendor collaboration, a successful foundation platform at Rogers, various data centers are operational today. Then I will join the conversation in providing you how VMware is enabling Rogers to build on its foundation platform, its 5G network, and offer cloud-based services with seamless automation, connectivity, and operationalization in a multi-cloud deployment. With this, let me hand over the floor to Bryce Mitchell from Rogers. Bryce, the floor is yours.
Good day, and welcome to our session on driving 5G network evolution with VMware. My name is Bryce Mitchell. I'm Vice President of Core Network Engineering here at Rogers Communications, and I'm pleased today to be discussing this important topic with you. Here at Rogers, we've been on a journey to transform our entire network to a cloud-native virtual-based solution, primarily based on the VMware software stack. Before I delve into the details of that, I wanted to briefly introduce you to Rogers Communications in case you haven't heard of us. We're a Canadian media and telecommunications company. We provide services from coast to coast here in Canada, covering 97% of the Canadian population. We offer services across mobile as well as fixed internet services, traditional telephony services, TV, media, and sports. We were the first in Canada to bring 5G to the country and the first in Canada to launch 5G standalone services, one of the first in the world as well. And we've been investing heavily in network with over 60 billion invested in the past 35 years. Our 5G leadership really began in early 2020 when we brought the largest 5G commercial network to Canada, now reaching more than 50% of Canadians. And by the end of this year, we're on target to reach over 1,000 communities and more than 70% of the population, making it and continuing to make it the largest 5G deployment in the country. I'd like to note that this year that Rogers was named one of the number one overall amongst Canadian wireless carriers in voice, data, and reliability for both our 4G and 5G networks. And this is the third year in a row that we've won this award from Umlaut. We've also won 5 awards from OpenSignal for our 5G network, including reach, availability, voice application experience, 5G gaming experience, and 5G upload speeds. We've recently invested $3.3 billion in the 3.5 gigahertz band spectrum auction, which is slated to cover 99.4% of Canadians. As you can see, Rogers is very serious about our investment in 5G and continue to drive the best and most powerful network forward for the country. So I'd like to talk to you about VMware and where VMware fits into the picture of our journey to deliver 5G to our customers. And so when we started on the journey with VMware, we really sought to achieve 4 major objectives. We wanted to ensure reliability, and especially in these COVID times, it's exceedingly important to us that we have a robust and reliable network that Canadians can depend upon for their communications. We wanted to make sure that we drove more efficiency, so automated manual tasks, took the human element out of things as much as possible so that we could have more efficiency and less error-prone tasks. We wanted to make sure that we had the ability to easily scale our capacity and have elasticity in our capacity. Again, with COVID, this was driven into sharp relief that oftentimes we need to rebalance our capacity across our wireline and wireless assets in real time. And we also wanted to drive quicker time to market, faster upgrades, the ability to deliver new and novel services to our customers in a more efficient and more quick manner. But of course, we also wanted to drive down our operating costs and capital costs as well too. And we've achieved a lot of this through really embracing cloud technologies across all aspects of our business and by driving to a common cloud platform with VMware. And that's allowed us to be more efficient, to be more centralized in our automation endeavors and activities, and to drive greater efficiencies of scale. We're partway through our journey in transforming our entire network, not just 5G, to a cloud-based solution. We're right now in between a heavy network functions virtualization or NFV type of deployment for most of our network functions and are transitioning towards cloud-ready and cloud-native applications. As I'm sure many people on this forum are very well aware, virtualization was the first step towards embracing cloud technologies for the telecommunications space, and Rogers was no exception in diving into that early and investing heavily in that space. And we've achieved many of our goals in this space, having virtualized a number of our critical network functions across both wireline and wireless services over the past couple of years. But now we're transitioning to really getting at the full value of cloud, and that's by building automation on top of our existing virtualized infrastructure. So automating our build and run, automating our testing, moving in towards an infrastructure as code and a new way of thinking and working that this technology unlocks. We're also deeply and heavily invested in moving towards a cloud native based architecture. So really getting at that full benefit of cloud technologies with a fully automated life cycle with deep, rich insight across our network, and aligning this to our long-term strategy. This is really where Rogers sees our network completely evolving to over the next couple of years. So we'll transition from a predominantly legacy to an entirely cloud-native space over the next number of years. The first major initiative that we have in this space is 5G. 5G really provides an opportunity for us as an organization to dive into cloud native technologies. It is in a large part a refresh of our architectures and a start new of an entirely new set of software and capabilities. And so we wanted to take the opportunity to do that right, to do that cloud native from the beginning, and to do that with our partner VMware. Very briefly before I dive into that, I just wanted to mention that we have a large and robust common cloud infrastructure that we call Rogers Common Cloud, or RCC, that is really coast to coast across Canada. And so you can see in the diagrams below that we have infrastructure from Vancouver all the way through to Montreal in the east, and soon we'll have even further deployments in Atlantic Canada. This deployment allows us to serve our customers where they live, to reduce latency by providing compute resources closer to the edge of our customers, and to improve reliability by having a geographically diverse and redundant set of infrastructure. And this has absolutely been instrumental and foundational for us in terms of our readiness for 5G across the country. Just to talk about our 5G architecture, as I mentioned earlier, it is an entirely cloud-native based solution that we're looking at deploying. And it is based on a lot of the standard functions that you would see and traditionally look for in a cloud-native 5G type of solution. So we have our core critical 5G network functions, such as the SMF and the AMF, and our UDMs and UDRs in more of a centralized type of deployment. We're also looking at exposing APIs to the NEF to third-party businesses. And all of this is our long-term strategy to have running on top of VMware Tanzu container-based infrastructure for our customers. As you can see, we're also putting the user plane on top of VMware and Tanzu as well. And we have kind of a multi-pronged approach on this. We'll have UPF and DPI analytic functions that will be centralized for some of our traffic where that makes sense. And we'll also have a distributed user plane function for edge computing type of applications where we really need to get that latency down for our customers, and where we have compute resources rather that are co-located with that user plane function for really low latency, high efficiency type of applications. It's absolutely critical in this architecture that we have the ability to scale quickly, easily, and elastically. As you can well imagine, especially when we get into a distributed type of architecture, we'll have to have quite a number of sites deployed across our country. We'll have to have functions that we can instantiate and tear down pretty much at will. And so it was very imperative to us that we heavily invested in the observability and automation capabilities that a cloud native architecture brings so that we can easily do that. We can no longer afford to work in a traditional way of doing manual testing and manual builds and long protracted type of application deployment into our production networks. The pace and speed with which 5G is evolving requires us to be able to rapidly deploy these functions into the network. We also recognize and have learned heavily, especially through our 5G standalone deployment experience, that the technology is early days. It's evolving. The plans for the industry are quite ambitious, and not all of them are available. Not all of the capabilities are available day one. And that's why automated testing and automated deployment of network functions is so absolutely critical to us, because we know that those development cycles and deployment cycles have to be extremely short in order for us to be able to stay competitive and to continue to take advantage of the 5G innovation that's occurring at such a rapid pace within our industry, if you will. And so that's why it was really critical for us to invest in a common cloud layer, and why we ended up, at the end of the day, selecting VMware as our partner. The depth of experience that VMware brings to the table, and the industry standard and solid software stack that they provide really allows us to focus on the innovation and deployment of 5G within our network, and so that we're not wasting time focused on the infrastructure and the plumbing underneath it, where our competitive advantage really isn't at this stage of the game. A little bit about what this looks like from a VMware perspective. If we do kind of look a little bit further down into the cloud software stack itself, we've created a self-service portal so that internally our internal customers can very efficiently self-serve without going through long, protracted ordering or provisioning activities for VMs and container instances that they need. We've heavily invested in a lot of the tooling that VMware brings to the table with vRealize Operations, vRealize Log Insight, and vRealize Network Insight, as well as Telco Cloud Operations, so that we have a very robust and standard set of observability, monitoring, and operational tools. We're also looking heavily at Telco Cloud automation for future orchestration and network slicing use cases to make sure that the actual infrastructure underneath is able to keep pace with those type of activities that happen at the application layer. And then, of course, we've heavily invested in Tanzu as our standard for our container management solution and platform as a service. Sitting on top of that is all the traditional VMware software stack that you may be used to with vCloud Director, vCenter, NSXT, vSAN, and vSphere, and so forth. And as I mentioned earlier, this is currently a coast-to-coast, rather large deployment that will be expanding into the edge as our 5G vision takes off and as we move to the next stage with that. So with that being said, I will turn it over to my colleagues at VMware, where they will dig in a little bit more into the actual technology at VMware that we've deployed at Rogers, so that you can get a feel for some of the underlying plumbing that's enabling our 5G solutions today here in Canada. Thank you very much for your time.
Thank you very much, Bryce. So my name is Stefan. I'm going to walk you through the architecture and the design and what we use to deploy the 5G architecture for Rogers and build something very evolutive for them. Can you switch to the next slide, please? So to build something that is going to be an infrastructure is going to be able to support 5G today and NextG, we had a global team, and the global team was built not just with VMware and Rogers, but also with all the vendors involved. So we built a team with VMware, Rogers, HPE, Cisco, and Ericsson. At the end of the project, even Intel was involved in that project. With that global team, we defined some design principles, and we also had a global team validation of the design. The principles are pretty simple, the three of them. The first one is we're just going to use best practice and consensus, meaning each aspect of the design is going to be based on the reference design from the different vendors and the best practice from the different vendors. But not just that, we work in a collaborative manner to bring those best practices together because in some case, for example, they're not aligning. The second design is pretty common nowadays. We're going to use a pattern-based design. There's going to be no snowflakes. We're going to have just patterns that we're going to apply, and we want to limit the number of flavors we have of each pattern. And the last one, and this is to be able to scale easily, is everything needs to be repeatable and homogeneous. So it's easier to manage. I can switch to the next slide, please. So when leveraging best practice and consensus, the easiest way to do that is to base your design on reference architecture. On the VMware side, you're not going to be surprised. We use the VMware Telco Cloud Platform reference architecture for that. Everything has already been designed, tested, and approved. This is something we can repeat, and we are sure of the performances and the capability of the platform. So we deployed 6 data centers across Canada, and we're going to see later how those data centers are connected together. And we use a 3-pod architecture. As you can see on the schema, we have the usual management pod, a networking pod to make sure that networking is not on the path of anything else, and then workload pods of different flavors. You can see we have 2 flavors here. The BOM was a multi-vendor BOM that was validated with all the vendors again. And down to the firmware level, down to the driver level, this is the advantage of using a reference architecture, is all of that has already been tested. And for anything that is not yet tested, the global product team was able to pull validation just on demand. Good example for that, we had an issue with a particular driver for an NIC card, and the application from Ericsson required an updated driver. Unfortunately, that driver was not on the validated list, so we went through the validation cycle. HPE and Intel have done some due diligence to make sure it's all okay. On the VMware side, we validated the design, and the design was updated with the new driver, and we were able to deploy successfully the application with that. On the same level, the networking design is quite critical for any telco application. So networking design was driven by the network functions requirements, and it was for every single step of between connectivity network cards and where the network cards are placed in the servers, always validated by Rogers, Cisco, and VMware, and even at that point, HPE and Intel actually. Can you switch to the next slide, please? So pattern-based design, something that I really like. Lego are superb. Everybody loves playing Legos. So we had one pattern, which was the management design. So we have one management design, and that's it. Only one flavor of management, always the same size, always configured the same way. No surprise. And then we have 2 flavors for the pattern that was for the workload domains. We have one flavor that we called high performance. As you can guess, this is where the data plane is going to live. We use all the features from NSXE, DNS data path, and so on. We have 100% resource guarantee on any single component, compute, memory, storage. Everything is 100% guaranteed. And we use a latency sensitivity set to high on those machines to ensure a good NUMA locality, not just for compute, but for compute, memory, and networking, meaning your I/O are going to be served by a network card that is the same NUMA node as where the application is running. And we also design a deterministic network path, meaning when you connect to a network path, you exactly know which path you're going to take, and you exactly know to which store you're going to end up. The top of rack can be very specific for network functions, as they can do BGP peering with the top of rack and so on. So you need to know where you're going to end up when you connect to a port group. On the other hand, we had other functions. Not everything is data plane, and that's pretty happy actually. So we have what we call general population. This is pretty much for everybody. Control plane, management plane, and even Mano was living in this pattern. This one has flexible resource guarantee, meaning we can provide from full guarantee to like half of the physical guarantee. Depending on the workload, it really depends what the workload requires. We had networking multipathing, but it was not deterministic. It was based on Cisco best practices to use active-active on the VPN fabric with an LACP bundle going down to the host. And we also achieve a higher density on that design flavor because we needed more density on that side. Again, not the same objective as the high performance, so we can make some compromise there. Can you switch to the next slide, please? Something very important, when you play with Lego, you can repeat. You can design the same set again and again and again. This is exactly what we've done here. We divided the Canada in 3 regions. Pretty simple, East, Central, and West. Nothing unusual here. Each region has redundancy built in, meaning each region was 2 data centers actually, and each region has its own Mano instance. Why do we use 2 data centers per region? It's really simple. Each data center being totally autonomous, it can serve its own traffic, but it can also be the backup or the overflow of its peer in the same region. So data center that is EAST1 can serve for EAST2 if EAST2 goes down, or can serve for extra bandwidth if EAST2 doesn't have enough bandwidth. From an NSXT standpoint, each data center was a single NSX fabric, meaning you can bring down any single data center, it won't have an impact on any other one. To go down that path, each data center also has its own complete management stack. From every single component, from management to monitoring to log collection and so on. Only one of the central region has, we call it an autonomous consolidated operational view. So we had a single VROps instance, virtualized operation instance, that was allowing Rogers to see exactly what's happening in all the data centers from a central place. And for that, we leverage the virtualized operation federation management pack. Now, let me hand over to Rajan, who will articulate how VMware can support Rogers' 5G vision with the new technologies such as automation and network slicing that are being introduced. Rajan, the ball is yours.
Thank you, Stefan. You just heard Bryce talk about Rogers' mission, their 5G vision plan. And for Rogers to be successful, Bryce also laid out key technical areas like orchestration, automation, cloud-native infrastructure deployment via continuous integration, continuous deployment type environment, network slicing, standards alignment, multi-cloud, and security. Now, let me share with you what VMware has introduced in these areas so that we can make Rogers successful with their 5G and NextG deployment on a common platform architecture that has been deployed in multiple locations, as Stefan just alluded to. Now, the first of this area is on automation and orchestration. Now, this area has become very key when you especially consider cloud-native application and its deployment across hybrid cloud infrastructure. Now, VMware has introduced during the last 1 year a telco cloud automation stack that can seamlessly work on top of the infrastructure foundation layers that Rogers have already built. Now, this automation layer can support complete network service automations to a very granular level of, say, a NIC level or a SRIOV type interface level with capabilities that any network function, be it a VNF, a CNF, or a microservice form factor, can be deployed. Now, with the automation being based on TSCA, which stands for Topology and Orchestration Specification for Cloud Applications, any vendor virtual network function manager can interface with this automation layer. In addition, there is ability to support very vendor-specific VNFs and generic VNFs that are meeting HC compliant SOL 1 descriptors and thereby provide a complete container as a service workflow model which can use Cloud Service Archive, which are normally known as CSAR files. These are deployable then across multiple clouds using the telco cloud automation. Now, at the same time, you could further have infrastructure level automation. It could be in terms of onboarding VNFs, onboarding CNFs or any XNF configurations, setting up latency sensitivity mappings, doing scale in, scale out based on network threshold levels and all of it, do operations like upgrade, patching, self-healing of the network, all from the automation and orchestration stack. All this helps to increase the operational efficiency and at the same time reducing cost and then also ensuring alignment with standards like HC, TMF, 3GPP, ORAN, and those type of specification. Now, having talked about the orchestration layer, on top of this orchestration, VMware is also building its network slicing architecture. This is another key area that can enable Rogers to maximize the use of the infrastructure in order to provide the various cloud services to specific business or applications of interest by taking this entire pool of resources, whether it is compute, storage, or networking, and slice from this pool and create logical networks with well-defined SLAs and guaranteed quality of service. Now, to meet this need, VMware is introducing this network slicing in a manner that it can enable various or domain level as well as end-to-end network level slice management at the same time, have interfaces that are aligned to open standards and specifications. Now, as you can see above, you will notice two levels in our network slicing architecture. The upper level is where the business intelligence, in order to create and manage the end-to-end network slicing, providing northbound and southbound interfaces exist. Now, at this layer, you have the communication service management function identified as CSMF and the network slice management function NSMF, which have been built as per guidelines in 3GPP 28.53. Now, this common layer communications can communicate with different domain-specific slice management functions, which can be for FIG access slice management, edge transport slice management, or a 5G core domain slice management. Thereby, you can have differentiated service offerings based on slice-specific quality of service, meeting those specific use case needs. Whether it is a use case related to a connected car, the use case related to a smart warehousing, or any of this, or any IoT or URLLC or MMTC type use cases. Now there is a separate session at VMworld very specifically on this topic and going in depth on network slicing, that is a network of the possible. Please plan to attend that session when you have time. The next area is for 5G and its deployment across a multi-cloud ecosystem. And that is to gain operational efficiency as well as service assurance across the Rogers cloud. Now, to help with that, VMware is introducing this Telco Cloud Operations. It's called TCOps for short. As can be seen on the left here, the Telco Cloud Operations stack logical layers integrates with various in-house or third-party management entities across a multi-cloud architecture. Now, as we do this, because there is this cross-domain capability for the Telco Cloud Operations to look at both the physical layer, the virtual infrastructure layer, it can do fault and performance management correlation, analysis, and then ascertain what a service impact is, whether it is the physical layer, the virtual layer, or the networking layer, and helps to appropriately mitigate, reduce problem areas, mitigate risk, reduce downtime for this at a services component level, or it could be at a tenant level, be it at a CNF level or a VNF level. All this is possible with telco cloud operations. Now, and finally, with many of the 5G entities, when you start to look at the RAN, at the core, the edge, as far as operational actions are concerned, there may be faults, events, and performance operational measurements that needs to make an assessment across different areas. So that in order to do this, some level of closed loop action and assessment is needed. And that happens across the telco cloud operations, telco cloud automation, and the telco cloud infrastructure, thereby providing one with an end-to-end operationally efficient deployment for day two, and thereby saving cost. Now, again, there are other separate sessions at VMworld, very specifically where we talk about assurance of 5G core and RAN, which you may want to consider. Now, finally, on the area of multi-cloud strategy, when one has to provide content on demand across various remote sites, in this era of cloud-native, highly distributed 5G and NextG architectures, building a multi-cloud architecture will sort of become the baseline as we go forward. Now, Rogers have already established a very strong foundation that has been built to date, and they can leverage that foundation to deploy this multi-cloud operation on the same infrastructure base, maintaining security isolation boundaries. Now, the public cloud can be leveraged where an economical benefit without security risk exists, or say where a geo access challenge may exist, or where an ad hoc environment for edge computing or a DevOps type environment is needed for development. Now, VMware offers support across all major hyperscalers, as you can see at the bottom, in both on the public on or off-premise options. Again, as you know, the theme of this year's VMworld is multi-cloud. So there are more than 50 plus sessions on multi-cloud. So feel free to attend any of that. Now, to summarize the session of Rogers and VMware, what Rogers have been able to realize is the true multi-vendor support that can exist with a VMware platform foundation. The coordination and collaboration seen during the deployment process has shown the need for a strong ecosystem collaboration can help and lead to achieve the Rogers mission. Now, the common platform architecture is enabling Rogers to deploy any vendor, VNF, CNF, or XNF on commercially off-the-shelf hardware. And this truly gives the freedom of choice to select the best of breed and innovative business logic they want to deploy and become leaders in 5G and NextG. Rogers has set the foundation to be the VMware platform. On this platform, 4G, 5G, 6G, what we mean is a generation of agnosticity. Evolution path is possible so that one does not have to build a separate silo platform for 4G, a separate one for 5G, a separate one for 6G. The common platform architecture enables that evolution path in a very seamless manner. And by deploying all the needed tools and driving automation and orchestration, Rogers envisions a high level of operational efficiencies and savings. So finally, in summary, the collaboration Rogers and VMware have had to date shows the technological readiness and the willingness of both the companies to drive the NextG revolution across Canada and to make it a reality. Both VMware and Rogers appreciates everyone attending this session. Please take your survey about the session. And as always, VMware thanks you for attending VMworld and this session.